In this video, I'm going to solve an example based on the potential difference. This is for the physics class. So here is a question. A proton moves along the x-axis where some arrangement of charges have produced the potential difference. So it's a sinusoidal waveform. Sinusoidal waveform we usually represent with Vx equal to V max sine omega t. Okay, sine omega t or 2 pi x over lambda. I mean, both of them are representing the same thing. Where V naught, which is the maximum value, V naught is also called amplitude, that is given as 5000. And lambda is the wavelength, that is also given as 1 mm. I don't think we're going to use the lambda value in this example. So the question he's asking about, what minimum speed must the proton have at x equal to 0 to move down the axis without being reflected. So here an electron is at the origin. So let me redraw the sinusoidal waveform one more time. So here is my sinusoidal waveform, which is amplitude is 5000. So maximum value is 5000. Now the electron is right here. Now this electron is going uphill. So the voltage, the potential at this point is 0 volt and the potential at this point is 5000 volt. So potential is changing from 0 to 5000 volt. Again, from here to here, potential is changing. This is minus 5000 volt. So potential is changing plus 5000 to negative 5000. So there is a 10,000 volt difference. That's a peak to peak value. Anyway, the basic rule we know is we cannot create energy, we cannot destroy energy. So all we can do, we can convert one form of energy into another form. So I know that kinetic energy plus potential energy final value must be equal to kinetic energy, potential energy initial value. Okay, so the final value, kinetic energy is half mv square, where v is the velocity. Potential energy is, when it comes to the kinematics, we use mgh, right, based on the height. But when it comes to the electrical side, that value is q times voltage, where voltage is the potential. Okay, so here this v is the voltage, so do not get confused between velocity and voltage. Now kinetic energy final is half mv square final. That's a velocity, and q times v final. By the way, this is final, this is initial, sorry. So this must be initial here. Okay, now here the initial, when it comes to, these are all final velocity. So he said axis without being reflected, right? So we're assuming the potential at that point is going to be 5000 volt, but at the same time the velocity at that point is going to be 0. So the final velocity, I'm taking that as 0, and there is a final voltage, so this value becomes 0, and q and v, we have some value. Same thing here, when it comes to the initial, we have initial velocity, speed, that's what we need to find, but initial voltage at this point is 0 volt. So once we substitute the values, so you need to know the mass of the proton, which is 1.67 times 10 to the power of minus 27, and you know the charge of the proton, 1.602 times 10 to the power of minus 19 coulombs. So once we substituted the values, we end up with initial velocity as 97.94 times 10 to the power of 4 meter per second. Now when it comes to the part B, in part B, what is the maximum speed reached by the proton that at x equal to 0 has the speed you calculated in part A. So it started with this velocity, initial velocity 97.94. So electron is started here with 97.94 times 10 to the power of 4 meter per second. Once it reaches here, what happened to the speed? Speed becomes 0. So now I'm going to take this as an initial, and what is the maximum speed it reach? It will reach the maximum speed when it reaches to the down point, because we see the highest potential difference right here. Okay, so in part B, the final velocity must be, so I'm going to use the same formula, Ke plus Pe final equal to Ke plus Pe initial, but it's going to be reversed because the potential energy here, you have potential energy there, but kinetic energy is going to be 0. Same thing when it reaches here, vice versa. So the final velocity when it reaches here, that's what we're going to find. Or he's talking about what is the maximum speed it reaches. I wouldn't say there is no potential energy there. There is definitely, because of the negative 5000 volt. But however, so the final velocity based on this, the only difference is going to be the potential difference. Instead of 5000, now we'll end up with 10,000. Okay, so the maximum velocity it will reach 2 times 1.602 times 10 to the power of minus 19 times the potential difference is going to be 10,000 times 10,000 divided by 1.67 times 10 to the power of minus 27. Okay, so this is our final velocity. Probably it's going to be square root 2 times, so that's what you have, right? Times 97.94 times 10 to the power of 4 meter per second. This is our maximum speed that proton can reach when it reaches to the lowest point of the waveform. Thank you. I'll stop it here.